Okay guys, welcome back. We're going to do this little question here. Before we do this question though, I just want to talk about this formula for a second. I want to make sure that we are able to transpose it. Really there's only a couple of possibilities for transposing this thing. You are either solving for xc, in which case it's 1 over 2 pi fc. You could be solving for f, okay, and you could be solving for c. Those are the three options. So I'm going to go over it with you on how this thing would get transposed the long way. All right, guys, but there's a shortcut, and I'm going to show you that as well. Forget about this question for a second. We're going to do it in a minute. Right now, I just want you to see this formula being transposed. So if I write down that formula, let's say, guys, that we are solving for frequency f, okay? The way I would do that is, well, the first thing I notice is that this entire formula is a fraction. There's a fraction in this formula. If there's a fraction in the formula, the rule is to start, you multiply both sides by whatever's on the bottom. Okay, that's always true for every formula that has a fraction in it. Step one, multiply both sides by everything on the bottom. It ends up being xc times 2 pi fc is equal to 1 over 2 pi fc times 2 pi fc, because whatever you do to one side of the equal sign, you must do to the other side. Now, we haven't really transposed it, but what we've done is simplified it a bit, because now on this side I have 1 divided by this times that, and it means those two actually get, eliminated, and I end up with a formula that looks like this: xc times 2 pi fc is equal to 1. Now, it's not transposed. I still don't have f all by itself, but I can now transpose this, and in another step, I want the f all by itself, so I'm going to divide all this by all the other stuff that I don't want, okay? So I don't want the xc, the 2, the pi, and the c, so I'm going to divide by that, and if I do that on one side, I must do it on the other side. Okay? And what that means is, or what that does for me is, it eliminates this, 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 and leaves that. And what I end up with is the formula is solved now. F is equal to 1 over 2 pi, c xc, okay? Now I want you to notice that when I was solving for xc, it's 1 over all the things, okay? If I'm solving for f, it is also 1 over all the other things. And as it turns out, if I happen to be solving for c, the formula for c is also 1 over all the things. Yeah, like this, okay? So it's basically, the three possibilities are right here. I don't care what you're solving for. It is 1 over all the other junk. All right, guys? So no big deal. I've showed you how this gets transposed. You might have to do that on your homework and sometimes when we're doing our work, okay? So now you know how to do it. Now, forget about that. Let's see if we can actually solve for this question right here. It's 100 volts, 375 microfarads, and we're trying to calculate xc and I. All right, guys? Now, we know what the formula is, piece of cake, right? So let's do the formula. xc is equal to 1 over 2 pi fc, which means it's 1 over 2 times pi, whoops. Okay, I forgot to give you a frequency here, times 60 times, now the capacitance has to be in farads, and this is currently in microfarads, okay? So how am I going to get from microfarads to farads? Well, the way I'm going to do it, because their micro is millions, I'm going to move the decimal place back 6. So this is going to become 0.000375. All right, guys? So now I've converted it from microfarads to farads. And while we're here, guys, I'm going to actually show you a couple of things. We'll finish this one in a second. but just forget about that for just a second. Let's talk about some values of microfarads just for fun, and we'll see what that looks like. We could have an example like this, 40 microfarads. We could have an example like this, 295 microfarads. We can have an example like this, 1200 microfarads, okay? And what I'm trying to show you is I've got a 2-digit value, a 3-digit value, and a 4-digit value. Now, when I'm converting those to farads, I know I'm going to have to move the decimal place to the left 6, which means I'm going to put 4 zeros in front of the 2-digit one, 3 zeros in front of the 3-digit one, and only 2 zeros in front of the 4-digit one. Basically, what I'm trying to tell you is when you're converting from microfarads to farads, make sure it has 6 digits in it, okay? Because then you won't screw up, and I don't want you to screw up, okay? Notice 4 digits because there was 2. I added 3 zeros because there was 3. I added 2 zeros because there was already 4, okay? So a little tip on helping you convert from microfarads to farads, all right, guys, no matter what the number looks like. Now, let's do this, XC. Now, there's a bunch of ways I could do this, guys, and I'm going to show you the Van Andel way, always the Van Andel way, okay? You can do it however you like, but I always pound all this stuff on the bottom in, and then I hit the 1/x button. So if I were to calculate this here, I'd go 2 times pi times 60 times 0.000375, and then I would hit equals. That is all that, okay? And then I would hit 1/x, or x to the minus 1, which is going to put a 1 over it. 1/x equals, okay? And according to this, it's 7.074 ohms, okay? 7.074 ohms. All right, guys? So 2 times pi times 60 times all that, hit equals. Then hit 1/x, and you'll put a 1 over all that stuff. Now that we know that this is behaving like 7 ohms in the circuit, guys, we can calculate the current in the circuit because that's the only gadget in the circuit that's limiting current. So I is going to be E/XC. All right, guys, and voltage was 100, and XC is 7.074. So 100 divided by answer equals, looks like the current is 14.1, 4 amps. All right, so this circuit, which is open because there's an insulator in there, is drawing 14 amps, and that's because all those electrons are piling up on this plate and this plate, and then leaving and going back around and moving back and forth all day long. All right, guys? So come back for RLC series circuits, which we're going to do on the next video. Have a good one.